How do we work with chemical solutions? Well, a solution is composed by dissolving a solute with a solvent, and enthalpy represents the amount of heat or energy in a system. There are 3 steps into forming a solution. First, the solute separates, so bonds are broken. This means that the heat, aka the energy, is absorbed, and delta H1 is going to be greater than 0. Delta H represents the enthalpy of this step. The second step is when the solvent separates and bonds are broken. This means that more heat, aka energy, is absorbed, and delta H2 will be greater than 0. Finally, the solute and solvent are attracted to each other, so bonds form. Heat/energy is released, meaning that delta H3 will be less than 0. What do we do with these 3 enthalpy values? In order to find the total enthalpy of the solution, we must add the partial enthalpies of each step. If the total enthalpy is greater than 0, then the formation of the solution was endothermic. If the total enthalpy of the solution is less than 0, then it is exothermic. So let's take a look at a problem. A liquid solution of carbonated water is made with gaseous carbon and liquid water. Find the total enthalpy of the solution. Is the process endothermic or exothermic? And we are provided with delta H1, delta H2, and delta H3. To calculate the total enthalpy of the solution, we simply need to add together the 3 partial enthalpies to find delta H solution. And we get negative 166 kilojoules per mole. Now, is the process endothermic or exothermic? Because the total enthalpy of the solution is less than 0, the process will be exothermic. Now let's talk about spontaneity. A process is spontaneous when it can occur independently, or when the process does not need outside energy. And spontaneous processes happen when delta G is negative. So the following equation will be able to tell us whether or not delta G is positive or negative, meaning that we will be able to know if the process can happen spontaneously or non-spontaneously. Keep in mind that entropy, or delta S, is a measure of disorder in the system. So there are 4 possible cases. If delta H is negative and delta S is positive, then the process is spontaneous, because delta G will equal a negative number minus a positive number, which will always be a negative number. And if delta G is negative, then the process is spontaneous. If delta H is negative and delta S is also negative, then the process is spontaneous at low temperatures. This is because delta G will equal a negative number minus a negative number. So, if T, or the temperature, is large, then delta G will be positive, since this term will get larger, and that will mean that delta G will become positive. However, if T is smaller, then delta G will be negative. So, when temperatures are low, the process is spontaneous. If delta H is positive and delta S is also positive, then the process is spontaneous at high temperatures. This is because delta G will equal a positive number minus T times a positive number. So if T is large, that will make delta G negative. But if T is small, that will make delta G positive. So at high temperatures, the process would be spontaneous. If delta H is positive and delta S is negative, the process is not spontaneous, because delta G would equal a positive number minus T times a negative number, which is always a positive number. So let's look at the problem. The change in enthalpy and entropy for a certain reaction are 31.7 kilojoules per mole and 179 joules per mole Kelvin. Calculate the change in free energy, or delta G, at 25 degrees Celsius. Is the reaction spontaneous, non-spontaneous, or at equilibrium? After converting Celsius into Kelvin and converting joules into kilojoules, we can now use the equation delta G equals delta H minus T delta S to solve for Gibbs free energy. We get delta G equals 31.7 kilojoules per mole minus 298.15 Kelvin multiplied by 0.179 kilojoules per mole Kelvin. And delta G comes out to negative 21.67 kilojoules per mole. Now that we've calculated the Gibbs free energy, is the reaction spontaneous, non-spontaneous, or at equilibrium? Well, the Gibbs free energy is negative, so therefore this reaction is spontaneous. Thanks for watching. Like and subscribe.